Hello, hi, my dear students. Today we can continue reverse biasing. Forward biasing we did. Now we can start with reverse biasing. Okay. So in the last class, just an introduction we have done. That is reverse biasing. It is known as what? False connection. You remember that? It is actually called as false connection. False connection means here in the PN junction diode, the P type is connected with the negative terminal of the battery and N type is connected with positive terminal of the battery. Just a reverse, opposite of forward biasing, right? So how it will be? In the block diagram you can represent this is P and this is N, P, N. In the P type, the majority charge carriers are holes, right? Holes are the majority charge carriers. In between, minority electrons will be there. In N type, the majority charge carriers are electrons, and in between, some minority holes will be there. So this is the depletion layer, and here positively charged ions will be there, here negatively charged ions will be there. Now this figure will be thorough, I guess. We are repeatedly drawing in forward biasing PN junction diode. Now it is easy, right? Now reverse biasing means P type will be connected to negative terminal of the battery and N will be connected to positive terminal of the battery. Correct. Now this is the representation of reverse biasing. Fine. Now negative, positive. Okay. Now here in the external battery, positive to negative, electric field will be in this direction, right? Internally in the depletion layer, there will be a potential will be created and that electric field will be always from plus to minus. In this case, both the electric field are directing towards same direction. That means the net electric field will be high in this case, right? Here, so the second point you can note it as here, the net electric field. Net electric field will be high, right? It will get added up. So the net electric field will be high. If the net electric field will be high, that is, if initially the depletion layer, the potential barrier was like this. When electric field high means the depletion layer widens. Then the potential barrier will be high, right? Potential barrier increases. Since the depletion layer widens, what happens? The potential barrier increases. That points you can note. That is, the net electric field is high, means the depletion layer widens. The electric field is so high, the depletion layer widens means now the electron movement is not easy, right? So the current will not be there. Otherwise, we can tell there will be negligible current. Okay. So here, what happens? Depletion layer, this point is important. Depletion layer widens, right? And potential barrier increases. This thing happens when the electric field increases, right? The net electric field is high here, so the depletion layer widens. So here the movement of electrons is again not possible. It's not favorable for the electron movement from N type to P type. Okay. So now, due to this situation, we need to apply a large external voltage in order to have some movement of electron. High external voltage has to be applied. So that point also you can write. That is more external, what will be the point? More external voltage is required to constitute current. Okay. So there will be a negligible current here and the current produced will be measured in microampere. Okay, not in milliampere, it will be measured in microampere. that much negligible current, and that current is produced, it is due to, this negligible current is due to the minority charge carriers. It is due to which charge carriers? Minority charge carriers, you can write. Minority charge carriers. Okay. How this minority charge carriers came here? Let us look at here. We know that here negative charge, right? And this negative charge will be repelling the electrons is the minority charge carriers, in P type is what? Electrons. This negative charge will be repelling this electrons since they are like charges, right? And this plus charge will be repelling what? Holes in the N type, sorry. Okay, one more thing is happening here. The electrons is get attracted by this plus charge, and the holes here is attracted by this negative charge. So the electrons from here will go to there, and the holes from here will come here. They will diffuse. There is now movement of charge carriers, right? And the movement of charge carriers is which charge carriers? Minority charge carriers, right? Here in P type the minority charge carriers are electrons, and in N type the minority charge carriers are holes. So this negative charge will repel the electrons, at the same time the plus charge here will attract those electrons. So it will go there. And this plus charge has repelling also is there, also attraction of this plus minus charge is also there. So minority charge carriers movement will create a negligible current which is measured in microamperes. Okay, this will happen in reverse biasing. And if you want to plot graph of this reverse biasing, if we plot here voltage of reverse biasing, here current, initially it will be constant, then at a point of voltage the current will increase suddenly, and this name you remember, this voltage after which there will be a large current. At this point the current is constant, right? For the voltage increasing the current remains constant. After a particular point of voltage, suddenly current increases, and that voltage is known as breakdown voltage. That name you remember, okay? Breakdown voltage. Okay, so this much points you can study or remember in this reverse biasing. Once again I will wind up. So reverse biasing, it is a false connection. P is connected with the negative terminal of the battery and N is connected with the positive terminal of the battery. And the both directions of electric field will be in the same. So the net electric field will be very high. So the depletion layer widens, and now the electron movement is not favorable. So more external voltage is to be applied to constitute some current, and the current will be measured in microampere, and the current, that negligible current is produced is due to minority charge carriers movement. Okay, so hope it is clear. Next class we can continue with this. Some more topic is coming important like Zener diode, solar cell, like that we can continue the class of physics. Okay, till then.